Hello geometers, this is Miss Backfish and I am here to talk to you about angles that we find when we're dealing with circles. Angles that are inside or outside or around or in or through, somehow related to a circle. Now, there's a lot to unpack here and I will acknowledge that the reason I'm making this video right now is that I just made one a little bit ago that ended up being 40 minutes long and I was like, whoa, way too long. So there's a lot to talk about and I'm going to try to be more succinct here, so I'm going to move kind of fast. And I want to remind you, when you're watching a video, you can always hit pause and replay a section. You can always stop and think about it, draw it, work it through, watch it as many times as you need to. Skip sections you don't need to, whatever you want to. Keep that in mind, that you are using this video interactively. So here is the main question we're going to be asking ourselves as we look at these. The key idea, there's lots of different scenarios that could create an angle in, around, or on a circle. And the key idea we're going to use to separate them into terms of how are we going to work this problem? How are we going to figure out how the angle and the inscribed arc and the other arcs and angles around it interact? And that key idea is exactly this. Where is the vertex? That's what we're going to keep in mind in terms of how we define this. So, for instance, the vertex could be outside the circle. The vertex could be inside the circle. Or the vertex could be on the circle. And those are our three main ideas in terms of the categories we're going to be putting our angles into. Outside, inside, or on. And every time you hear me say outside, inside, or on, we are specifically talking about where is the vertex of the angle we're dealing with. So outside, inside, and on is specifically talking about where is that vertex. And it turns out that there's basically a formula we can kind of use for each one of them that tells us how the angles and the arcs interrelate, okay? And here is the one for outside. Here is the one for inside. And here is the one for on. When the vertex is outside the circle, it turns out that the angle is going to be half the measure of the angle is going to be half the measure of the difference, half the difference between the two arc measures. Now, what two arc measures? Well, anytime we have our vertex outside the circle, it turns out that angle is going to intercept two arcs, not one. And we'll talk more about that in a second. Inside, when the vertex is inside the circle, the angle measure is half the sum. Difference is subtract, sum means add. I'm going to add the two arcs. What do I mean about the two arcs? We'll talk more about that. But when we have our angle inside the circle, we're going to have two intercepted arcs. And then finally, when the angle vertex is on the circle, it's kind of like an inscribed angle. We only have one intercepted arc, and our measure of our angle is just half the measure of the arc. So these are the big three scenarios and also the equations that we're going to use for each scenario. So let's go ahead and look at some of those. We're going to start with the easiest one, which is what about the vertexes on the circle? Now, before we get to this particular topic in circles, we've already dealt with two types of angles already. We learned about central angles, where their vertex was at the center of the circle. That's definitely not on. But we also learned about inscribed angles, and their vertex is on the circle. An inscribed angle has two sides that are both chords. So an inscribed angle fits into this category as well, which means the rule that we have for this category right here does apply to inscribed angles. So we already know that. So the three examples I'm going to give you are not necessarily of inscribed angles, but of three other scenarios where we have the vertex on the circle. First scenario is we have a tangent and we have a chord, and they intersect at a point on the circle, at the point of tangency. That creates a couple, actually, of angles where the vertex is on the circle. Here is one of the angles it creates, and that particular angle intercepts this arc. The other one is over here, and that particular angle, trying to make it, there you go, intercepts this arc. Notice that together those two arcs make up the whole circle. So I'm going to go ahead and I'm going to name those angles angle 1 and angle 2. All right. Angle 1 would be half of the arc over here that it intercepts, the blue arc. Angle 2 would be half of this arc. So let's suppose that I am given the measure of the blue arc, and I'm asked to find the measure of angle 2. Well, there's a couple of different ways I could do it. I could say, okay, I'm going to find half of that, and that'll give me this angle. And then these two form a linear pair, so I can subtract from 180. Or I can subtract the 188, the arc, from 360 to find this arc over here, and then take half of it. So you're doing half and you're subtracting. You could either do it with the arcs. Let's do it that way first. If I know that this is 188, then the rest of the circle is 360 minus 188, which is 172, which means this arc is 172, and then I take half of it, and half of 172 is the same as just dividing by 2, and that gives me 86. The other way I was suggesting you could do it, and it's really just personal preference, is you could have said, I'm going to start, instead of subtracting, I'm going to go ahead and find this angle by doing 188 divided by 2. And then I'll do my subtraction and subtract the angle 1 from 180 to find angle 2, because those two form a linear pair. And that also gives me 86 degrees. So it works either way. Okay, another scenario, and this is really practically the same thing, is I have a tangent and a secant that meet at the point of tangency. Same idea, and my angle has a vertex on the circle. So in this particular case, it's asking me to find the measure of arc AC, and I haven't finished giving you the problem yet. We need some information. We don't really have any information yet. Let's go ahead and say that, I'm going to say that this particular angle right here, let's do this one. This angle is 76 degrees. Okay. Well, arc AC is over here. Remember, it doesn't ever hurt to trace the two sides of the angle and trace over the intercepted arc. In other words, this is the angle that intercepts that arc that we need to find. So if I could find that angle, then I could find the arc. And yeah, these are vertical angles. Okay, the 76 and this all the way across here, that's also 76. So angle is half the arc. That means the arc is twice as big as the angle. If I do 76 times 2, that will give me 152 degrees. And that is my answer. A final example I want to show you of when the vertex of the angle is on the circle, and this one looks just like an inscribed angle. The only difference is I made them lines and continued them outside the circle instead of just chords. Makes no difference to how we find the angle, but it does make a difference in what's making up the angle. I've got two secants making up this angle, and the vertex is on the circle. So if the angle is half the arc, well, we could start with this angle and double it to get this arc. And let's go ahead and trace the angle in the arc. Here's the angle that goes with this arc. Okay, or we could start with the arc and take half to get that angle. What if we start with this information and we're asked to find the angle measure? Okay, well, I've got two arcs, the 100-degree arc and the 84-degree arc, and that's the whole circle except for the green part. So that allows me to subtract from 360 to find that one missing arc, which is the arc I need to know. And that arc is 176 degrees. If the angle is half the arc, then I'm just going to divide that by 2, and I get my answer is x is 88. All right, so those are my examples for when my vertex of my angle is on the circle. Let's go ahead and next look at what about when it's outside the circle. Okay, when the vertex is outside the circle, this is what we said our rule was, that the angle measure is half the difference between the two arc measures. Well, the question then becomes, what two arc measures? What are you talking about? This is the first time we've had two intercepted arcs. So here's probably the most simple example, is when you have two secants as the sides of your angle, and I'm going to go ahead and trace those over. And what that does is those two sides chop off two parts Here's one part of the circle, and here's the other part of the circle. So I have two intercepted arcs, two arcs that are between the two sides of my angle. So those are my two pieces. Now, the next question is, I'm writing this in a very generic way just to make it easy to say and remember. But these aren't the same arc. They're two different arcs. Which one do I subtract from which one? Well, we want positive angle measures. So to get a positive number, you need to subtract a bigger minus a smaller. So we always start with the bigger angle. The bigger angle is going to be the one that's farther away from the vertex. So the farther away arc, I'm sorry, I think I said bigger angle. I meant the arc minus the closer arc, the bigger arc minus the smaller arc. So in this particular case, the measure of angle 1 is equal to 1/2. Notice the 1/2 is still there, just like with on the circle. 1/2 of 94 minus 38. So I'm going to do 94 minus 38 in my calculator, and then divide that by 2, because that's an easy way to take half. And I get 28. So the measure of angle 1 is 28 degrees. For our next problem, we're going to move right over here to the side, but I want to compare and contrast here a second. What's different about this figure from this figure? Well, over here, my angle is formed by two secants. Both sides of the angle touch the circle in two places. Over here, my angle is formed by a tangent, line QR, and a secant. But we're going to treat it the same way because it still has its vertex outside the circle, and that's the key fact we're using here. Okay, so outside, the angle is half the difference between the two arcs, so I need to know what my two arcs are. So here's the two sides of my angle. So the two pieces of circle that are between those two sides, and I'm going to use a couple different colors this time. Here is one piece. Okay, that would be arc QT. That's one intercepted arc. And here's the other piece. Arc QS is the other intercepted arc. All right, the problem here is I don't know the measure of arc QT. So first, okay, so my video recorder cut out in the middle of that problem, and I'm not exactly sure. So let's just restart looking at this one. The vertex is outside. These are my two intercepted arcs, the green one QT and the blue one QS. The problem here is I don't know the green arc measure. So what I'm going to have to do is I'm going to have to find it by taking the two arcs that I do know, the 104 and the 87, and subtracting from 360 to find that missing green arc QT. So 360 minus 360 minus 87 minus 104, or you could add them together first and then subtract if you want. That tells me that arc QT has to be 169. So now I have all the information I need to be able to fill it in here and solve. So the measure of angle R, that's the angle, is 1/2 the difference between the two intercepted arcs. 169 minus, difference means subtract, minus 87. Okay, 169 minus 87 is 82. 1/2 of 82 is 41 degrees. So that's the measure of angle R. In our next example here, our vertex D is formed by two sides that are both tangents to the circle. So here's one side, here's the other side. That means my intercepted arcs are this one that's labeled X and arc ABC. In other words, the long way around the other way on the circle. So those are my intercepted arcs. Those are my two arcs. Now, this one's actually a little bit more challenging. Just because it's two tangents is not what makes it challenging. We can have easier ones that are like that. This is challenging because I'm not told what that bigger arc is. And I'm not even given a number for the smaller arc. But in order to figure out what I'm going to do for this bigger arc, I need to think about what would I do if I did have a number. What if that was 100 degrees? What would the pink arc be then? What would arc ABC be? if x was 100? How would I find out? Well, I would subtract from 360 because together these two arcs make up the whole circle. So I'm still going to subtract from 360 even though I don't have a number. I'm just going to call it 360 minus x. And now I can use this formula to write an equation. My angle, which is 80, equals 1/2 of the bigger arc, which is 360 minus x, minus the smaller arc, which is just x. So 80 equals 1/2 of, and when I get rid of these parentheses, this is really just 360 minus x twice, so that's minus 2x. And I can distribute my 1/2. 80 equals 1/2 times 360 is 180. 1/2 of 2x is just 1x. Running out of paper here. So I'm going to subtract my 180 from both sides, and I get negative 100 equals negative x. And what do you know? I literally didn't even realize it was going to come out that way when I said, what if x was 100? But x is 100, it turns out. And that's how you do a problem like that. Last but not least, I wanted to show you one where it's pretty straightforward. It's actually very much like this first one we did, where we have two secants and we have our two intercepted arcs, and they're fairly easy to see. Here's my angle. There's one intercepted arc, and here's the other intercepted arc. But the difference here is I'm not trying to find the angle, I'm trying to find one of the missing arcs. And so I still use the exact same equation, it's just the difference is going to be what's missing. If I know the angle, I start out with angle equals, so 42 equals, because I'm told the angle is 42, 1/2, the bigger arc is 135, minus the smaller arc is x. Now, I could go ahead and distribute and take half of 135 and half here. So I could distribute, but that's going to give me, since it's odd, it's going to give me a decimal. And that's fine. You could do it with a decimal, but I want to show you a little trick here. I could, when it's like this and have a number out front, I could get rid of this number out front and not have to impact this at all by multiplying both sides by the reciprocal of my fraction, meaning flip 1/2 over and you get 2. If I multiply both sides by 2, then the 2 times the 1/2 just turns into a 1. And it doesn't even affect at all what's inside there. It's pretty cool. And over here we've got 2 times 42, that's 84. And over here, this is gone now, and I just have 135 minus x. So I can subtract. I don't know what that is off the top of my head. That's negative 51. And that's negative x. Divide or multiply both sides by negative 1, and we get x is 51. All right, and that's outside. Vertex is outside the circle. Last but not least, we're going to do the ones where the vertex is inside the circle. Okay, so last but not least, we have vertexes or vertices, or the vertex is inside the circle. All right, so for instance, right here is a vertex of my angle, or right here. And notice there's multiple angles I could be talking about here. There's 4 different angles here. And anytime, remember, you have 2 lines crossing, it doesn't matter if they're inside a circle or not. If 2 lines cross, remember you have vertical angles, like if this is 70, and they're vertical angles. And you also have linear pairs. The ones next to each other add up to 180. So this one and 70, or this one and the 70 and this one. So 180 minus 70, this is 110, this is 110. So that's true whether or not you have a circle. So that's still true here. Wanted to show you a couple ways they could be drawn. 2 chords intersect inside a circle. Also, if I have 2 secant lines, they could intersect inside a circle. All right, so the first one I want to look at is maybe the most straightforward. Let's say this is angle 1, and I want to find the measure of angle 1. And what I'm given is this is 82 degrees, and this is 24 degrees. Now, what I'm talking about here is the 82 is this part right here, and the 24 is this part right here. Those are going to be my two intercepted arcs for the angle that is labeled angle 1. When you have your angle inside the circle, when the vertex is inside the circle, one of the intercepted arcs is where we'd kind of expect it to be. Meaning if I trace the two sides of this angle like this, there it is. It's in between the two sides of the angle. The other one is basically behind it. Like if you take those two sides and you extend them, because they're still going past that vertex, and you extend them out the back side of the circle, that intercepts your second arc. So when you have your vertex inside the circle, you could think of it as one of the intercepted arcs is in front of your angle, like your angle, the two sides of your angle are arms embracing that intercepted arc. And the other one is straight behind you. Like if you had eyes in the back of your head, you could look at it. So right here, I'm going to take my equation, which is the angle is half the sum of the two arcs. And I'm going to say, all right, then this measure of angle 1 has to be half, it's always half, the sum of the two arcs, 82 plus 24. With addition, it doesn't matter what order we add in, we can do it in either order. So I'm going to add 82 plus 24, and that gives me 106. Half of 106 is 53, and that's my answer. So that's a very straightforward example of a problem like this. Now let me show you a couple of twists that sometimes happen. The most common twist, perhaps, is if I was asked to find an angle. Let's move that down here. And I'm given that this is 30 degrees and that this is 92 degrees. You have to be on your toes with these to notice what just happened. What just happened? Well, what just happened is they didn't give me the arcs that go with my angle. The arcs that go with my angle are the ones in front of my angle and behind my angle. Okay, so the two sides, the two arms of my angle here are here and here. The arc that's between those is right here. So that's the one in front of my angle. And then also eyes in the back of my head pointing at the one behind my angle. These, the two that I've both marked in orange, those are the intercepted arcs for angle X. 30 and 92 are not. So there's a couple of ways we could do this. One way is we could say, well, how about if instead of finding angle X first, what if I find this angle next to it first? We just said they're linear pairs. In other words, this angle right here. These two have to add up to 180. And this does go with the 92 and the 30. So what if I do that one instead and then subtract from 180 to find X? That's an option. So if I do that, I would say the angle is half 92 plus 30. So let's do 92 plus 30 and then take half of that. So that tells me this question mark angle is 61 degrees. And so if I wanted to find X, I can just say, all right, 61 subtracted from 180 because linear pairs are supplementary. 180 minus 61 is 119 degrees. So X is 119. That's one option. Let's look at it the other way. This other way I want to look at it, I kind of think I favor it just because I think it's a little bit clever. All right, when you look at this, you think, oh, I don't know these two arcs. I have to find those two arcs. Like I need to know this one and I need to know this one. But no, you don't. You don't actually need to know individually the two arcs. Look at the formula. You need to know what they add up to so that you can take half of their sum. Well, these two arcs are the only thing that's left in the circle if we took the 92 and the 30 out. In other words, 360 minus 92 minus 30. This number is these two arcs put together. The 238 is what these two orange arcs add up to. And that's really all I need to know for the formula. So I can say X is 1/2. The sum of the two arcs we just said was 238. So 1/2 of 238, that is Believe it or not, I've already forgotten what we got for the last problem. 119. We get the same thing, and to me, that's a little bit quicker. So if you understand that, great. That's one way to do it. If you like it better the other way, you could do it the other way. All right, last two problems. I'm coming in fast here. It's not always the angle that we're looking for. I just wanted to point that out. What if this is 82 degrees and this is X degrees and this is 104 degrees? Okay, the angle is half one arc plus the other arc. So angle 104 is half of one arc plus the other arc. We could either distribute this 1/2 or we could get rid of it by multiplying both sides by 2, which I favor. So I'm going to multiply both sides by 2. That means on the left I'll have 208. On the right, this guy cancels out and I just have 82 plus x. Subtract 82 from both sides, and 208 minus 82 will give me my answer. So even if we're not trying to find the angle, we still use the same formula. Okay, this is not really technically a formula, but we're treating it like one. All right, we use the same formula. It's just a difference of which part is the x, which part is the unknown. And the final thing I want to point out to you here is this. These rules that we've come up with, and let's go ahead and just summarize them real quick. These pretty much apply to every case of angles and circles. There's one case we haven't talked about though. We did talk about how inscribed angles still go with this rule, still works for inscribed angles. However, what about central angles? Do central angles not fit any of them? They actually still do. It's just a little bit weird how they do. So let me just point that out. Here's a central angle. Let's say it measures 40 degrees. Well, so does this. Well, notice that's only one intercepted arc right here. If we extend the two sides of this central angle like we have all these other angles and go backwards past the vertex through the other side of the circle, well, because of vertical angles, it's also 40, and this is 40. So it's still true that my angle, there it is equal to half the sum of the two arcs. So it does apply to central angles also, but you have to extend the sides behind the angle, basically. So I just wanted to show you it doesn't contradict what we already know. All of it works together. And I appreciate your patience. We're right at 28 minutes, which is much better than 40. So I hope this works for you and has answered all the questions you want to know about circles and angles, and I'll see you next time.